So what happens when I take log base 7 of the right-hand side? What do you get back? You just get back the exponent, the argument in the exponent, right? You just get back minus kt. Right? So my stuff here is just minus kt. And hey, one more move, we got it. So little t is equal to log base 7 of t minus t naught over t1 minus t naught, all divided by minus k. And by the way, the meaning of this equation, right? Like for example, you know, you can if you have a specific temperature in mind, right? Like, you know, if we knew that you know, the initial temperature of the coffee was 120 degrees and room temperature was 70 degrees, and we wanted to figure out which time the coffee cooled to, like, you know, say 80 degrees, you could put 80 in for big T, and you'd have like 80 minus 70 divided by, you know, 120 minus 70. You take the log base 7 of that, and then you'd have to be given additional data to know what this K describes how fast the coupling of the, you know, how fast the energy is lost from the coffee cup to the air, right? Which would depend on the particulars of how the mug is insulated and how much surface area it has to, you know, let heat out and stuff like that. But anyway, yep.
Oh, one question. I probably should know the answer already. How do you determine when you use the log, or take the log of something, or the natural log?
Oh, it's really just a matter of preference in some regard. As a general rule of order, if I have two different bases involved, right? If I have two different bases involved and they're like not in any way related, like if I had like base 2 and base 3 involved, I tend to gravitate towards using a natural log, just because if I do like log 2 of 3, it's nothing nice. If I do log 3 of 2, it's nothing nice. So natural log is nice, is kind of a more standard thing to use for that kind of problem. But it's really a matter of taste. Like, you wouldn't be wrong. I wouldn't count your problem wrong if, for example, if like if I had 3 to the x equals 2 to the, 2x minus 1. I might take the natural log of this. If you took log base 3 of it, you wouldn't be wrong. As long as you do the steps right? So like, here's example 11. So this is x, which is what makes that nice. And this simplifies to 2x minus 1. And then here's the part which is not nice, but can't be avoided. And then you have to solve for x, Let me finish it here. So that's, x minus 2 log 3 of 2, x equals to minus log 3 of 2. You may have now noticed that sometimes I capitalize log and sometimes I lowercase log. There is no significance to that whatsoever. That is just something I do. I'm sorry about that. I would love to tell you there's some sort of deeper meaning in this course for that, but it's just not the case. There are other places in math where there's this distinction between capital and lowercase. Like in complex analysis, the capital log might be a particular selection, particular branch cut of the logarithm, whereas the lowercase log would be a multiply valued function. But anyways, here, so the answer would look like this, yeah? And if, in contrast, I had worked this problem using natural log, well, the answer would have looked quite different, But it wouldn't be wrong. Here, let me erase let me get rid of the clutter around this problem, yeah? So I lost you where?
You lost
So you're okay with this step?
Yeah, how do you
Okay.
not step to the next step?
To the next step. All right, so the next step, so what I did was, this is 2x log 3 of 2 minus log 3 of 2. It's like multiply, distribute, right? So I just distributed 2x times that, and minus 1 times that. And then I subtracted that to the other side.
You subtracted.
Like to go from here to here, so I subtract 2x log 3 from both sides. So basically I took this and moved it over here.
Oh, that's because the x is already there.
Right, so yeah, like it's plus here, and I move the x around, minus over there. And then I factored x out like this. Of course, I mean, if you want to, you could factor x out on the right. Does that make sense? We good? Okay. So like this problem, if instead of thinking, oh, I should do log base 3, I'd done natural log, what would have happened is I would have had natural log of 3 to the x, right? Equals natural log of 2 to the 2x minus 1. How would have that gone? Well, x log 3 equal to 2x minus 1 log 2. And then I would have brought all the x's to one side, yeah? X log 3 minus 2x log 2 equals to minus log 2. I'd factor out the x. I'd solve for x. So you see how I mean, is that right? Is that right? They're both right. They're fine. Either way, it's fine. So like your question of which log do you use? On problems like this, it doesn't matter. There are other problems where the log you use is basically governed by the base that you're looking at. You know, like if I've got 16 to the x equals 2 to the 3x, something like that, I probably should use, first of all, I need to see 16 as what? As a power of 2, right? So 16 is 2 to the 4. So I've got 2 to the 4x equals to 2 to the 3x. And then this one, I would say, that says use log base 2, right? And of course, we don't even really need to do that, right? Because even before that, we could just use the one-to-one property of the 2 to the x function, right? But if you like, I can do log base 2. And what happens is you get what? Which tells us what? Four minus 3 is 1, and so you had x equal to 0. Yeah.
Trying to think of a question.
Uh-huh.
Could you just as easily, well, there might be a problem with that, this problem. Could you just easily just bring 1.2 to 4x and then taking that 4x minus that 3x?
Oh, yeah, sure. There's another way to do this problem. So I could have multiplied both sides by 2 to the minus 3x, right? Or divide by 2 to the 3x, you like that? Is what you're thinking, maybe? And that would have given us 2 to the x equals to 1. And then if you know your facts about the exponential function, once you see that, you're like, oh, x equal to 0. The only way I can get 2 to the x equal to 1 is from x equal to 0, right? So if you know that, sure, that's another approach. There are many roads. Yeah. Anyway, I hope I've showed you enough for you guys to do your homework. See you next week.